In this problem, we're given the ratio sine alpha over sine beta that's equals to A. And we have the other ratio cosine alpha over cosine beta has a value of B. Now we need to find out the value of tangent of alpha and tangent of beta, and the answer should be in terms of A and B. So let's begin. First, we note down whatever we are being provided with. So here we are given sine alpha divided by sine beta. So this ratio has a value of A. We're going to label this as number 1. Then we have the other ratio cosine alpha divided by cosine beta. So that's equals to B. We're going to label this as number 2. So let's do one thing. Let's divide equation 1 with equation number 2. That means we have sine alpha divided by sine beta. Well, since we're dividing with cos alpha over cos beta, so that's simply multiplying it with the reciprocal. So we have cosine beta divided by cosine alpha, which will be equals to A divided by B. Now we can rewrite this. So we have sine alpha divided by cosine alpha multiplied to cosine beta divided by cosine sine beta, which will be equals to A over B. The ratio sine over cosine, that's the tangent function. So we have tangent of alpha divided by, so cosine of beta over sine of beta, that's a cotangent of beta, but if we take its reciprocal, so we have tangent of beta in the denominator. So we've got a new ratio, tangent of alpha over tangent of beta, that's equals to A over B. So let's label this as equation number 3. However, what we'll do, we're going to rewrite this ratio. So this ratio can be also be written as tangent of alpha over A. So that's equals to tangent of beta over B. So let's say that this is equals to some constant lambda. So that means tangent of alpha will be equals to lambda times A, and tangent of beta, that's equals to lambda times B. So that means if we can find out the value of lambda, we can easily obtain the value of tangent of alpha and tangent of beta. So our next task will be to find out the value of lambda. For this, we are going to start with equation number 1. So using 1, we have sine alpha divided by sine beta. So that's equals to 1. So let's manipulate this ratio. Now sine alpha over sine beta equals to A can be also expressed as sine alpha equals to A times sine beta. Now what we'll do, we'll try to convert the sine to the tangent function. So for this, we'll divide sine alpha with cosine alpha. Now since we're dividing with an extra term, we'll also have to multiply with that same term, cosine alpha. Similarly, on the right hand side, we're going to divide sine beta with cosine beta. And again, cosine beta being an extra term, we'll also have to multiply it to it so that the equation remains valid. And now sine over cosine, that ratio is the tangent function. So we have tangent of alpha times cosine of alpha, which will be equals to A times the sine alpha over cosine alpha, that will become tangent of beta times cosine beta. We know that our cosine function, so if we have cosine theta, that is the reciprocal of the secant function. So that means in place of cosine alpha, we can replace it with 1 over secant alpha. So we have tangent of alpha divided by secant alpha, which will be equals to A multiplied to tangent of beta divided by cosine of beta. So that will take its reciprocal. It will be 1 over secant of beta. Again, the whole reason for converting cosine to sine this time is we are going to use another identity. We know that secant squared theta, that's equivalent to 1 plus tangent squared theta. Since we need secant theta, so we have to take the square root. So this is going to give us secant of theta will be equals to 1 plus square root of tangent squared theta. So that means in our case, the denominator portion can be rewritten on both sides. So we are going to have tangent of alpha divided by, so we have secant of alpha in the denominator. This can be replaced with square root of 1 plus tangent squared alpha, which will be equals to A times tangent of beta divided by secant of beta. So secant of beta will be square root of 1 plus tangent squared beta. So now that we have tangent of alpha, we have already shown that the value of tangent of alpha, that's a times lambda, and tangent of beta is b times lambda. So let's replace these values here. So we have a times lambda divided by square root of 1 plus a squared lambda squared, which will be equals to a times, so tangent of beta will be b times lambda whole divided by square root of 1 plus b squared times lambda squared. We can cancel a lambda and a lambda from both sides, and we have 1 over square root of 1 plus a squared lambda squared, which will be equals to b divided by square root of 1 plus b squared lambda squared. Cross multiplying, that gives us square root of 1 plus b squared lambda squared equals to b multiplied to square root of 1 plus a squared lambda squared. So squaring both sides, we're going to get 1 plus b squared lambda squared equals to b squared whole multiplied to 1 squared a squared lambda squared. That gives us 1 plus b squared times lambda squared equals to b squared plus a squared b squared lambda squared. Since our task is to find out the value of lambda squared, so we can combine the terms. So we have a squared b squared lambda squared minus b squared equals to 1 minus b squared. So we can take a squared b squared minus 1, so this minus b squared, so this will be multiplied to lambda squared, which will be equals to 1 minus b squared. Further simplification is going to give us, we have lambda squared equals to 1 minus b squared divided by a squared b squared minus b squared. The lambda squared will be equals to, we have 1 minus b squared divided by, we can take b squared as the common factor, so b squared will be multiplied to a squared minus 1. Taking the square root on both sides, we can obtain the value of lambda. So lambda will be plus or minus 1 over b multiplied to the square root of 1 minus b squared divided by a squared minus 1. So we have successfully obtained the value of lambda. Now we can find out the value of tangent of alpha and tangent of beta. So tangent of alpha, which is equals to a times lambda. So that means we have plus or minus a over b whole multiplied to 1 square root of 1 minus b squared divided by a squared minus 1. And tangent of beta, that will be equals to b times lambda. So we have plus or minus, so b and b will get cancelled. So we have plus or minus square root of 1 minus b squared whole divided by a squared minus 1. So this is going to be the value of tangent of alpha and tangent of beta.